Okay, everyone, welcome back. So as promised, we're going to get some direct internet access to our branch site A. We've currently got internet access through the WAN and out the data center. We're going to introduce direct internet access so that we can optimize our performance and keep our fellow workers happy here. So we're going to basically get a connection from site A, router 1, over to ISP A. Doesn't really matter, the interface is here. So let's get that connection up. We're wired in. Alright, good. And then let's go ahead and jump on router 1. Okay, so I believe from way back when we're gonna see some remnants here of internet access from when we did this way back when. So before we even did the WAN environment, we had done some internet access at site A and B for that matter. So we should be able to just reuse these IPs. There should be nothing wrong with that. Let's go over to internet ISP A. Let me get rid of some stuff here just because I got a lot of things open. So service provider router 1, right? Show IP interface brief. Alright, so sorry, this is the wrong box. My apologies. ISPA, that's what we want. Okay, 20 Gig 3, this is going to be the interface that we're going to configure, so we're going to want to get the other end of that E01. So let's check the subnet. Okay, so it's a /30, so that means 200.0.1.1 is going to be the service provider side, and look at that, we already have our NAT on there, so that's perfect. Okay, good. So we're going to do 200.0.1.1. Okay, so we should be able to ping It's not the right address. 0 dot. Okay, good. So we have basic connectivity over to router 1, right? So that's a good thing. So what we need to do is let's on the internet service provider, right? So we have all the BGP stuff running. So all we're gonna do here, just because I want to make sure that this /30 link between AR1 and ISPA, I want to make sure that gets advertised into the internet and doesn't create a black hole for us. So I'm gonna play the role of the service provider, and I'm gonna go under the address family, and I'm just gonna put the network statement in for this /30 subnet. Okay, so what that's going to do is for instance, on the internet loopback, show IP route. So we should, the 200.0.1, okay, show IP. Just want to check this router too. I want to make sure I didn't duplicate an IP address. Okay, all right, good. All right, so on AR1, we have the BGP route that is telling us how to get to the internet right now, right? So we advertised that in the last video. It propagated all the way to the WAN. So what that's telling the site is to go over the MPLS to reach the internet. So we want to overthrow that, right? We want to go directly to the internet. So And in this case, we're not peering BGP. So, maybe this is a cable modem that we have connected to Cisco Site A. It's just like a fast, low-cost internet connection that, we're trying to take advantage of. So we're not going to be doing BGP, but we need to overthrow that route. So we could just introduce a static route, okay, and point it directly to ISPA. All right. So let's go ahead and do that. Let's add an IP route quad 0, and that's going to go out 200.0.1.1. Okay. We'll give it a name. We'll say ISPA. We'll call it DIA, right? We'll just call it DIA. Okay, so that, as soon as I put that static route in, that should overthrow that BGP route, okay? Because it's got the administrative distance of 1 versus the BGP route had the administrative distance of 20, okay? So obviously the 1 is way better than the 20, so it gets installed into the routing table. So can I ping 8888? Okay, I can. Let's trace route to 8888. Let me do a no IP domain lookup. Okay, so see the difference here. All right, so before, we did it from the server or the PC, but when we trace routed before, we went through all these hops, right? And we know that anything that's a 192 address is our WAN environment. So if we don't see the 192s, we know that we're not going across the WAN. So that's a quick and dirty way to kind of know that and the amount of hops, right? So now we've gone through considerably less hops to reach 8888. So that's a good thing. Let's just make sure our NAT is all in place, because I don't want a half config here. Because remember, it was a remnant from before. So what we should see is on 0.1, okay, we have NAT outside. On 0.0, this is our inside interface, at least it should be. Okay, that's still there. And it looks like we still have our, okay, perfect. So let's, from PC3, let's ping, okay, so we can still ping the internet, right? But let's do that trace route again from the PC's perspective. Okay, so you can see it's much better, right? So that's good. Now, if we go back to here, okay, so there's our NAT translations. So we went from PC3, we can see that we NATed to the outside address for 200.0.1.2, and our destination was 8888 or Google, right? Things are looking good. Now, the one of the downsides with a config like this is that the static route on router 1, okay, is just that, right? It's static. It's never going to go away, all right? So, for instance, complete. If I fire up a ping and I do a count of, let's say 1,000, right? So let's make this bigger. Let's slide him over so we can watch. And then on router, basically what I'm going to do is I'm going to shut down gig 3 on ISPA, okay? So the internet, somebody hit a telephone pole in the area, it took the internet down, maybe there was a fiber cut, choose your analogy. But the problem here is that we lost internet completely, and it's never going to come back, okay? Because we put a static route in our router that is always going to chuck all the traffic over to ISPA. Well, in this case, we lost ISPA, so that's not good. We know that we have a working MPLS connection that we could take advantage of if a situation like this happens. So what do we need to do to handle a situation like this? Well, we've already looked at IP SLAs and tracks, and that's in our arsenal of tricks. or it's in our tool bag, so why not take advantage of it, okay? So let's go ahead and get that put in place, and we can do a test and see if we have better results, okay? So first things first, let's re-enable the gig 3. So let's just bring him back up. All right. Okay, so internet has been restored. Fiber crews have spliced fiber, that we're back up and running. Good stuff. Until the next time there's a cut, right? So let's try to get ahead of that. So what we can do is on router 1, if we know that we can ping 8888, right? So what we can do is we can create an SLA or a track based on reachability to 8888. So what do I mean by that? So if we trace route to 8888, right now it follows that default static, okay? But we want to eventually modify the static or tweak it in a way that it's not always just superseding the BGP route, whether the internet's up or down. So let's create a static route for 8888. And the purpose of this route is going to be for tracking the state of the internet through ISP-A, if you will, okay? So we're going to do a /32 host route, this is called. So this is only, this route only applies to 8888, okay? We're gonna set it to be the same next hop as ISP-A, all right? So that shouldn't change connectivity to 8888 in any way, shape, or form, okay? It should still work, all right? All it did was just put a more specific route into our table for 8888. So now we have a /32 route. So in theory, we're following this route as opposed to the static, all right? So for example, just to kind of reinforce the point, show run, include route. If I take out this route, I should still be able to ping 888, right? So that's just to kind of prove that we are using the more specific route, all right? So I won't put this route back in yet because we're gonna be tweaking it, all right? So what we want to do now is we want to create an IP SLA, okay? So to do that, we type IP, we'll hit the question mark. There should be a command for SLA, IP service level agreement. So we'll do IP SLA, and what it wants is a number between 1 and whatever this is. So we're just going to say IP SLA 1. We'll hit enter. It drops us into IP SLA configuration mode, okay? So what we want to do now is we want to just basically ping 8888, okay, to verify that it's up and working. So in other words, by forcing the 8888 traffic through ISP-A, okay, and throwing or wrapping an SLA or pings around it, this is a great way for us to kind of constantly check whether ISP-A is up. So that's kind of what we're looking to do, all right? So how do we do that? We're going to say ICMP echo. Okay, what's the destination IP address that you're trying to target here? Well, in our case, it's 8888. Okay, we can tie a source interface or source IP. In this case, we shouldn't have to do that. Okay, we've taken care of the specifics as far as the static route goes. So we'll just say, I just want to ping Google. All right. You can adjust the frequency. You can do some other kind of things in here. For this case, we don't need to do that. However, what we do need to do is start the SLA. So when we show IP SLA summary, it says that it's basically unknown, and it's got some weird random last run timer, which is just a product of iOS. We need to start this. We have to start it with a schedule. So what we need to do is IP SLA schedule. We'll just give it 1. I always match my SLAs with the schedule. There's no reason to change those numbers, right? We want to say start time is now, we want to say life is forever. Very weird command by Cisco, but once you remember it, you probably will never forget it. So what we're saying is we want to start the SLA now and let it run forever. All right. So if we do show IP SLA summary, so now what we see is it gets a return code of OK, and it was last run 5 seconds ago. Excuse me. So that's a good thing. So now our router's just doing nothing more than pinging 8888 over and over and over and over again. But it's doing it over ISP-A's internet, right? So there's one more piece to this puzzle. So remember that default route that we took out of our config. So we don't have the default route. We need to put that default route back, okay? But what we're going to do is we're going to tie the SLA or the track to it, okay? So, and I should have said there's 2 more pieces, because now we have to tie a track to the SLA, because when you put a route in, let me just show you. If I hit the question mark, there's no option for SLA. It's only track, okay? So you have to tie an SLA to a track. So in order to do that, you say track track 1, okay? What do we want to track? We want to track the list. Sorry, not the list. That's if you want to, you can bundle multiple SLAs together and do booleans. It's pretty cool. We want to track 1 IP SLA. What's the SLA number? It was 1. And we want to track its reachability, okay? So now if we show track, so we have this object, track 1, that's measuring the reachability for SLA 1, and it's going to be either up or down, okay? So now what we can do is we can take that route. So let's scroll up and see if we can find that route that we had. Here it was. So now this time we're going to put the route back in, okay? We're going to point it out ISPA. We can still give it our name, but now we can track it based on the track that we just built, okay? So let's see what effect this has on the routing table, okay, if any. So it still shows as a static route with an AD of 1, right? It doesn't look any different than it did before, okay? So let's go back. So the pings are still going. Looks like we're about halfway there, so we should have enough time here. So the pings for PC3 are still going. We have our track and our SLA built. Everything looks like it's good. Everything's happy. The route's back there. So let's go back and shut this gig 3 interface. So let's introduce the same failure that we did last time. All right, so we obviously took a hit, right? But the question becomes, is it going to have a better effect? All right. So what we need to do here is we kind of have to wait, because we didn't tweak any timers or we didn't make any adjustments to our tracks or our the SLA. We just left it all at default. So we can see the SLA just timed out. Okay, so it can no longer reach 8888. Now check this out. It says tracking state 1, reachability has gone from up to down. Okay, so our track statement, so if we show track, now our reachability for SLA 1 is down. Okay, well that's looks good. Show IP route. So look at that. The static route has fallen out of the table And now we have the BGP route, okay? This might need to be stopped and started, by the way. These PCs are a bit of a nuisance. So let's just, and I don't know how to break it. Yeah, I don't know how to break the ping on the VPCs. Let's just reconnect to PC3. Ugh, he's just gonna keep on pinging, isn't he? I guess we can go to PC2. Let's just do that. I'll have to look that up, guys. I'm sorry. Show IP. And of course, I don't know what VLAN I think he sits in 200. Yeah, he's in 200. So we'll say IP is 10.1.1.12. His gateway should be 10.1.1.1, right? So can we ping the internet? Let me just double check, right? Zero, zero, yeah, 200. I want to see if I can ping. What did I want to try here? Show IP SLA summary, right? We know that that's gone. We know that the routing table adjusted for BGP to take precedence. Oh, right. Bad example. I'm getting ahead of myself. Of course, 8888 is not going to ping because we're pointing it out the interface that we took the internet down. I'm a complete and utter moron. So if we try to ping 4222, right, that's probably a better test. There we go. So I would have been troubleshooting that for a long time, right, because that was really foolish on my part. So if we trace route to 4222, look at that. So everything we configured worked perfectly, right? So let me bring up, let me bring that interface back up and just do it one more time, right? So let's come back here. Let's no shut. Fiber crews fix the break, right? ISPA should be coming up here shortly. These pings will come back because obviously that static route is pointing over that one link. So there, okay, so there's our connectivity back, right? So what I should probably do is fire up a ping to 4222. It's probably a better test. Okay, it's still there. Let me do a trace to make sure it flipped back. Nope, not yet. So we need to make sure that our traffic comes back. So the BGP route's still there, right? Okay, so there's our SLA, or track, I should say. It came back up. Okay, so the static route just came back automatically, right? So now if I go to PC2 and I do the trace, that's better. So now we're doing direct internet access, right? So let's do a ping. So let's ping 4222 and we'll do a count of 750. Okay. So let's do this one more time. We can see kind of what our convergence looks like. All right, so if we go to ISP-A, and let's shut that link down. And we can watch the status from the PC's perspective as well as our router's perspective. And again, you can adjust this so it's faster. I'm just giving you the basics of the default timers and such. Okay, so check that out. So we've effectively just given our branch site resiliency to the internet by taking something that we already had in our arsenal, which was SLAs and tracks, and we now have, again, provided some level of redundancy for our users. So we've given them direct internet access, which made them happy because now they're faster, and we've also given them a backup internet in case that modem goes down or whatever the case may be. So this is a good example of how you can leverage, again, CCNA, CCNP type tools, right? This isn't super difficult to do, but we can apply them into more of a real life situation. So I hope you got something out of that. Let me bring that interface up. That is a tried and true method to provide, basic resiliency at a branch site and have multiple connections and take advantage of both. So I'm going to stop there, and we'll continue to kind of expand on some of these ideas and concepts and see how much more we can provide to this topology. So I will see you guys on the next one.